right, guys, so this is lesson 2.2, scalar and vector quantities. We're going to talk about the difference between the two and where you're going to see them, how we're going to use them. This is more of an introductory lesson, but this stuff's pretty important. We're going to use a lot of vector quantities. I did color code scalar words or terminology in red and vector terminology in blue. You will see that throughout the slideshow. I'm going to define a few key terms first. Position, that is the location of the object. If we're measuring something, we're going to track its position, especially when we're dealing with vector quantities. Velocity is the change in position per time. Acceleration is the change in velocity over time. And you guys have already been introduced to speed, distance, time, probably a couple others, but those are the main. So if we're talking about scalar and vector quantities, scalar quantities are quantities that only have magnitude, meaning I only know the size of what they are. So like if it's miles per hour, I know it's 100 miles per hour. 100 is the magnitude. It's how big it is. 50 is less than 100. 100 has a greater magnitude than 50. You get the hint? So that's magnitude, and that's specifically that's in scalar and both scalar and vector, but scalar only has magnitude. Vector has both magnitude and direction. So it won't just say 100 miles per hour, it'll say 100 miles per hour west or 100 miles per hour forward, things like that. So when we're dealing with vector, we're specifically talking about displacement, which is the change in position from origin to final destination. And when we're talking about speed, we're only talking about distance covered. So speed is going to take into account the trip, whereas displacement takes into account the origin and the ending. So how we describe magnitude and direction, this is important, is we use arrows. And we use these on force diagrams in the future, but for now, I just want you to get used to seeing the difference between the two. So if we were talking about, if we put a compass right here and it said north is up and west is left, and right is east, and south is down, right? If you just put a compass on there facing north is facing up, you would say that this magnitude is greater than this magnitude, but they're facing the same direction. So they're both pointing east, however, this has a greater magnitude. I say this because magnitude is represented by the length, the size of the arrow, not the width, but the length. And direction is the direction of the arrow. So we use magnitude and direction with arrows, specifically in force diagrams, but we may use it in some other stuff. So in this case, this would be a smaller magnitude than this, and this would be about the same magnitude as this, but they're pointing different directions. So this is some different examples. So ask yourself, if I were to say, hey, what is a small magnitude pointing west? Well, you would look at this. This arrow is significantly smaller than the rest, and it's pointing in the left direction, which I said was west. So you probably get the hint. That's basically what we do. We use magnitude and direction, and we use arrows to describe those things. So how are speed and velocity different? I know a lot of students that interchange the two terms, but they're not as interchangeable as you may think. They're measured in the same units, which makes things confusing. You might find both of them measured in meters per second, but one of them might have a positive or negative, or maybe a direction, north, south, east, west, up, down, left, right, that kind of thing. And that's vector. So that's how we can kind of differentiate between the two. And then also the numerator in their equation are different. So speed is distance traveled. This is, I'm traveling 60 meters, okay? And it's within so many seconds, within 1 second. So I'm traveling 60 meters in 1 second. This says nothing about direction. It only gives me the 60 meters per second, which is a type of magnitude. 60 is the magnitude. So in this case, this would be speed. The bottom one actually gives me a direction. It says northwest. So that's a dead giveaway. That's a vector. We're talking about velocity here. So this is 40 miles per hour displaced northwest. So that would go right here. 27 yards per hour south, again, giving me direction. Velocity, that's vector. right? You guys kind of get the hint. You guys can do 10 in your head. It's speed. It's scalar. So I'm going to give you a quick example of this, why these are different. Let's say you were to measure you and your friend getting dropped off on a bus, okay? And you guys are both heading for the door, right, to go play some video games. You walk a distance of 21.2 meters. You cut right through the yard and you head straight to the door, while your friend goes down the street and up the sidewalk, and he walks a total distance of 27 meters. So if you guys get there at the same time, your speed is going to be different, right? You will have to walk significantly, or your friend will have to walk significantly faster to cover the same amount of distance or a different amount of distance in the same time, right? So your friend's going to have to, since he's walking a longer walk, he's going to have to walk faster, right? But you're walking significantly slower. So your speed is going to be different. Your friend will have to walk faster if you want to get there at the same exact time. However, you have the same displacement, which means your velocity is going to be the same. Because in velocity, we measure from origin to final destination. And you both have the same origin and you both have the same final destination. Okay? So in velocity, it would be exactly the same. Your displacement would be 21.2 meters. So you see how that's different. Distance and displacement are two totally different things, and they're measured differently. And that's going to change how your velocity is taken or speed is taken. Another example here. So if you and your friend, or let's say you are walking in kilometers, you're walking for 9 seconds, 9 minutes, right? Yeah, minutes. You're walking for 9 minutes. You walk 6 kilometers in total. Okay, 3 up, 3 back. So you walk forward 3 kilometers and you walk backward 3 kilometers. You end up in the same spot at 0 kilometers that you started in. Your displacement is 0. You ended up in the same place you started. So your velocity would be 0 meters or 0 kilometers per minute. Okay? Speed is not the same. You walked 3 kilometers and an additional 3 kilometers. You walked 6 kilometers in 9 minutes. So you would have 2/3 kilometer per minute, or 0.66 kilometers per minute. So you can see how those are different as well. So just remember, speed can only be positive. Velocity can be both negative and positive, or 0. Speed, I guess, could be 0 too if you're not moving. But speed takes into account distance. Velocity takes into account displacement. So acceleration, is acceleration scalar or vector? Well, acceleration is the change in velocity per time. So if we measure velocity as a vector measurement with direction, acceleration is going to be the same way. And I said how, velocity can be negative or positive. So can acceleration. And that's how we get the term deceleration. We're going to talk more about this in the next lesson. But if you're decelerating, you're just accelerating in the negative direction. So that's just food for thought for the next lesson. Just remember, vector, we're talking about displacement, original spot, sorry, it's the bell, original spot and ending spot. Whereas if we're talking about speed, we're talking about distance, total trip, how long it takes. So that's it for now. We'll come back to this stuff next time. All right, guys.